Hey guys! Today I will show you how to do the sling mechanic from Angry Birds. This is what the end product will look like. We will have the ball, we will be able to drag it, there will be a line between the ball and the sling. You can let go of the ball, then it will go flying away, leaving a trail behind it. Great! Let's jump into Unity and get started. Alright, here I have opened an empty scene in Unity. I have imported my ball as a sprite. Let's move it into the scene. Change the size a bit to make it look better, like that. Give it a rigid body component. Keep it at dynamic because we want it to be able to interact with physics. Another component, a collider, so that it can collide with stuff. And now we need something in the scene that symbolizes the sling. So we can add another sprite. Let's call it sling. And set the sprite to a knob so that it's visible in the scene. Make sure the Z position is set to 0. Let's change the color to something more discreet, like transparent black, like that. Great. Now we need to connect the ball with the sling somehow, and this can be done using a spring joint. To me it makes more sense to add a spring joint to the sling, but for simplicity we will add it to the ball instead. Let's add the component. It's called spring joint 2D. Great. Now we can see that the spring joint wants to be connected to another rigid body, so let's add a rigid body component to the sling. Rigid body. You don't ever want the sling to be able to move or interact with physics, so we set it static. And then we select the ball and we can drag the sling into the spring joint component. Now we can see that the ball and the sling are connected by the green line. So let's put the ball over the sling and play and see what happens. Yes, we can see that they are connected. Perfect. Alright, now we need some to be able to interact with the ball. We can add a new script, call it ball, let it compile, and then attach it to the ball. Move into Visual Studio. So we can start by removing these. Then we need a variable to determine whether or not we have pressed the ball. So private boolean is pressed. And then on mouse button, when we have pressed the ball with the mouse, we will set the is pressed to true. So void private void on mouse down is pressed equals to true. And likewise, when we have released the mouse button, we want to set it back to false. Like this. In the update method, we will check for is pressed, and if it's true, we will change its position, the ball's position, to match that of our mouse. Is pressed, no. If is pressed, then we can drag the ball. Let's create the method. Private void drag ball. So for this we need to get a reference to our rigid body component. So we can do it up here. Rigid body B. In the awake method, we grab it. So RB equals to get component rigid body. And then when we are dragging the ball, we need to get our mouse position. So that is a vector 2 mouse position equals to camera.main.screen to wall point. This takes a position on the screen that we are seeing, where the mouse is interacting with, and translates it into a point in the Unity world. So it takes the mouse input.mouse position. And then we just need to change the position of our rigid body to be mouse position, like this. So let's try it out. Back into Unity and press play. We can see that if we press, it will follow the mouse. But we can also notice some strange behavior. The ball is moving even though the mouse is held still. And this is because the mouse is forcing the ball to move to its position, while the spring joint is a force that's trying to retract the ball towards it. So there are two forces working on the ball at the moment, and we don't want that. So what we will do is we will make the ball, the rigid body, to is kinematic when we are pressing it. So when we are pressing the ball on mouse button down, we grab the rigid body, set it to is kinematic. Then likewise, again, when we are releasing the ball, we set it back to dynamic. Okay, let's press play and try it out. Yes, we can now see that the ball is moving to where the mouse is without being retracted by the spring joint anymore. Perfect. Now we want the ball to be released when we release it and go fly away. We want the ball to be released about when it's over the sling and then keep on flying. So let's press stop, select the ball. We can see that there is something called frequency on the spring joint. And frequency is how many periods does it make in 1 second. One period is when the ball is starting over here, for example, and goes over here and then back to where it started. That's 1 period. So if the frequency is set to 1, it means it makes 1 period in 1 second. So that means we want the ball to be released when it's about here. That means on 1/4 of a period. Half a period, an entire period. So this is 1/4 of a period. So let's move and make it in the script. We need a reference to our spring joint to find out the frequency. We can do it the same way as we did with the rigid body. Spring joint. Spring joint SG. We need a variable release delay, how long time it will take from when we are releasing the ball to when it should let go. Is float release delay, and we will use the frequency to calculate the release delay. Release delay equals to 1 divided by spring joint dot frequency times 4. This is the simple calculation. The 4 is because it's 1/4 of a period that we wanted to let go. Great. Now when we have released the mouse, we want to run a method, start a coroutine to wait for a certain amount of time, release delay, and then let go of the ball. So we create the method first. So it's a private enumerator release, and here yield return new wait for seconds, and we feed it the release delay. And after that we will just take our spring joint and disable it like this. Then here we will call this coroutine. Perfect. Let's try it out. So now when I drag the ball and release it here, then it will take a few milliseconds and it will disable the spring joint over here and the ball will go fly away. Let's see if it works. Yes, it works perfectly. And now, since we are calculating the release delay, we can go ahead and change the frequency if you're not happy with the speeds. Let's try 1.5, and now we don't need to change anything else, and this is good for testing purposes. Now, move it, and the ball goes flying away even faster. Perfect. Okay, so now we want to restrict the drag distance, and as we can see now, we can drag the ball as far away as we want, but we want it to be restricted to a certain distance. So let's move back into the script, introduce a new variable, private float max drag distance, and we can set it to 2 units for now. We also need a reference to our sling, so we can get it by doing rigid body 2D and sling rigid body. And this one can be acquired quite easily. Sling equals to spring joint connected body. Remember that we attached the sling to the rigid body component. Now we can get it by doing this. Okay, and now after we have found our mouse position, we can calculate the distance from the mouse position to the sling. And do a vector 2 distance float distance equals to vector 2 distance. We feed it the mouse position and the sling position like this, and then we can check the distance. If distance is larger than our max drag distance, we will do something. If it's smaller, then we can change the position as we did before. So position, set it to mouse. But if it's larger than the max drag distance, we want to calculate the direction that the mouse is moved in the relative to the sling. So we need a vector 2 direction, and we set it to mouse position minus the sling position and normalize it, and then we can set the position of the rigid body to be that of the sling position plus the direction that we have moved towards times the max drag distance. Let's try this one out. Now when I drag the ball, it should be clamped. Yes, and it's clamped in the direction that I'm moving the mouse and 2 units away from the sling. Perfect. Now we're done with the main mechanics of the sling. Okay, so now we want to add the line that we could see in the beginning between the ball and the sling. We can do it by adding another component to the ball. The component is called a line renderer. Let's give it a default material of the sprite. Default. Change the color to something nicer, like purple, transparent purple. Then we can see that it needs 2 positions to be visible. You can add as many positions as you want, but we only need 2, one start position and one end position. So from the sling to the ball. Let's go back into the script. Grab a reference to our line renderer. Line renderer LR. Okay. Get component line renderer. like so. Then when we are dragging the ball, we will calculate and set the line renderer position. Set line renderer position. We create a method, private set or void set line renderer position, and we create a vector3 array of positions. Vector3 we only need 2 positions because we only needed one beginning and one end. Positions at the 0 element equals to our rigid body position, and the position at 1 position is equal to our hook's position. Then we need to set this position to the line render. Set position. You can see here that there are 2. One to set them individual, and one to feed it a vector array of position, like in our case. We only need to feed it the positions now. And let's see what happens. We see that, yes, there is a line going from the hook to our ball. Perfect. But the line isn't very nice looking, so we can change it a little bit. So let's start with changing width to 0.1 and add some end vertices. Okay, let's play again. Now it's much nicer, but we can see a problem here, a tube. First off, there is a dot here, the line renderer, so it's rendering at position 0 to begin with. We don't want this, so we can disable line renderer, but we do it in the awake as well, just to be sure. Enabled equals false, and we only enable it when we are dragging the ball, so holding the mouse button down on the ball. So enable to. Let's see if that fixed the problem. You can see that the line renderer is gone. It's not rendering at the 0 position anymore, and it's working now. But when we release, the line renderer is still here. So when we release our mouse button, we should disable the line renderer again. Enable false. There it is. There, and it's gone. Perfect. The line renderer is fixed now. So now let's add the tail render as well. Let's see what, add a material first. Change the color into some greenish, perhaps. Let's go with green. A nice green. And then, okay, we can see that wherever the ball goes is following by a line trail, and perhaps not what we wanted. So first off, we can change the properties of the line again, make it a bit nicer. So 0.1, perhaps 5, and yes, it's much nicer, but we don't want it to show at the beginning. We only want it to show when the ball is flying. So let's set this to disabled again, and then grab the reference to the tail render. Tail render tr. Component tail render, and disable it just to be safe. And we enable it only when we have the ball has been released. So here, dot enable equals to true. Let's try it again. We have the line, and here is the trail. Perfect. And there's a bunch of properties you can play with on both the trail renderer and the line renderer to make it nicer. So this was everything I had for today. I hope you enjoyed it and learned something new. Thank you and see you later. Bye bye.